Hey everyone, we're just going to go ahead and get started here with our very first video where you're going to be taking notes along with me in your student journal. All right, so if you open up your student journal, we're in page 4 right here. Okay, so go ahead in your student journal. And your page should look like my page, so from now on you don't need to print out notes or anything like that. You can just follow along in the student journal. All right, so I would take a minute. You should probably pause the video and get some of this vocabulary down. Right here, I would just title this Solving Simple Equations, because that's what 1.1, the title of 1.1 is. Okay, so solving simple equations. So you may need to pause this really quickly so you can get these vocabulary terms down. All right, so essentially, a conjecture, that's an unproven statement, so that's something you're trying to figure out if it's true about a concept. A rule and a theorem are the same thing. It's a proven statement. So if you're reading something in a math textbook that says this is always true, that is a rule or a theorem. An equation, when you have something that are equal on both sides of the equal sign, that's an equation. All right, that's what you're used to dealing with in algebra. So a lot of these we're going to be solving, all right, to find what the solution to an equation is. All right, I'm going to go ahead. Got a couple more terms. Again, if you want to pause so you can get all this vocab. All right, so we've got a linear equation in one variable. Means we can write the equation in this format. Sorry, my zero went all over here. You can write it like this. Okay, so you can have it written with just an x term, a constant term set equal to 0. That means it's in one variable. You're probably familiar of an equation in two variables would look something like this, but we're not quite there yet. All right, so we're just solving in one variable so we can find the solution. All right, and that solution is a value that makes the equation true. Okay, so this x minus 4 equals 2. We know that the solution is 6. The value that makes this equation correct is 6. All right, when x is equal to 6, this is true. Inverse operations, so two operations that undo each other. So addition and subtraction are one inverse operation. Okay, addition is the opposite of subtraction is what that means. Subtraction is the opposite of addition. And then multiplication and division are also inverse operations. Okay, they undo each other. And then equivalent equations are two equations that have the same solution. All right, so both of these have the solution of 4. Okay, so equivalent equations are a type of equation that are basically equal to each other. All right. So we're going to go through this, and we've got a lot of these properties. Okay, these are like those rule or theorem like we just talked about in the vocab. These are one of those things that kind of sound complicated and they're in the math speak, but once you look at this, most of you have seen this and it's going to be pretty simple. All right, so the addition property of equality. All right, that's one of those things that sound kind of confusing. It's kind of in math speak, so adding the same number to each side of an equation produces an equivalent equation. All right, all that means is if you have an equation, okay, A and B are equal to each other, well, then that means if I add C to both sides, then that's still true. They're still equal. All right, so let's see it in numbers because most of us, we think that's easier in numbers. Let's say we've got an equation. We've got this x minus 7 is equal to 13. So if we're trying to find the solution, we're trying to find what x is, we want to say, okay, well, let's add 7 to both sides. Okay, we've got x minus 7 plus 7 is equal to 13 plus 7. All right, I just wrote it like this so it could look like it does here in the theorem. All right, so I added 7, just like I add c to both sides. All right, negative 7 plus 7 is 0, so this is just x. 13 plus 7 is 20. Now, most of you, I'm pretty sure, are not used to seeing it like this, and I don't really expect you to write it out like this. Most of us, I'm pretty sure, have seen this like this. X minus 7 is equal to 13. We want to get rid of this negative 7. We want to get rid of the constant and have just x here on one side. So we're going to add 7 here to both sides. Okay, so negative 7 and plus 7 are going to cancel out. So I've got x is equal to 13 plus 7 is 20. All right, so most of us are probably used to working out this way. That's the way I kind of want you to show your work on these problems. All right, so again, this sounds a little bit confusing, but it's really just algebra that you've already done. All right, so let's go into, we've got one for each operation. So subtraction property of equality is the same thing. Okay, if A and B are equal, then you can subtract C from both sides and it's still going to be equal. All right, so let's do an example. Let's say I've got x plus 2 is equal to 12. Well, if I go ahead and subtract 2 from each side, here, so let me do it the way you're used to seeing it. Let's subtract 2 here from each side. I'm doing that inverse operation. This plus 2 and minus 2 cancel out, right? Positive 2 minus 2 is equal to 0. I'm left with x, and 12 minus 2 is equal to 10. All right, so x is equal to 10. You can always think about, does this make sense back in the original equation? All right, 10 plus 2 is equal to 12. Yes. All right, awesome. All right, you have your solution. All right, the answer, the value of x is your solution. All right, so we've got our multiplication property now. So as you can probably guess, just like addition and subtraction, it means when we have our equation, if we multiply each side by the same value, here we write it as c, if we multiply it by the same value, it's going to still be equal. All right, this one has an additional little rule here. C can't be equal to 0. All right, you wouldn't want to multiply both sides by 0, right? Because you just end up back with 0. Okay, so any value other than 0, you can multiply and it's still going to be equivalent. Okay, so we have, let's do x divided by 2 is equal to 4. Okay, let's multiply each side here by 2. Okay, so I've got 4 times 2. I want to multiply because multiplication is the inverse operation to division. Okay, and then I've got times 2 over here. Remember, if you've got a fraction and then just a number, you can change this to 2 over 1. Okay, our 2's cancel out here. X over 1 is the same thing as just x. Okay, you're canceling out, so you end up with just x. And then 4 times 2 is equal to 8. That makes sense in our original equation. Okay, 8 divided by 2 is equal to 4. So that's our solution. All right, then we have this division property. All right, which again, we can pretty much guess it's the same thing as the multiplication property, except when we have our little equation, we can divide each side by c. Same thing, you don't want to divide by 0. All right, you are not allowed to divide by 0. So any number but 0, you can divide both sides of an equation by that number, and you're ending up with the same equation. All right, so let's try. We've got 3x is equal to 15. All right, if I gave you that equation, you could use this division property of equality. All right, divide both sides by the same number. You're multiplying here, so you want to do the inverse operation. You want to do the opposite. So we're going to divide each side by 3. Okay, You have this 3 divided by 3, that cancels out. Okay, think about 3 divided by 3 would be equal to 1. All right, so I get x is equal to 15 divided by 3. Think about either dividing that or simplifying that fraction. Either way, you get 5. Okay, that makes sense. 3 times 5 is equal to 15, so that's our solution. All right. So go ahead, if you want, you can go through some of these extra practice problems to make sure you've got this down. Otherwise, go ahead and get started on your assignment. You can either look at the PDF that I posted or go into Big Ideas and use the textbook. But either way, you can go ahead and get started, and I'll see you guys tomorrow.